Hi, in this video, we're going to walk through the example from chapter 8 for logistic regression. So in order to do that, we're going to first go into R. We're going to run logistic regression, see what results we get. Then we'll export the results over and visualize some different ways of looking at the results in Tableau. So let's go ahead and start in R. So the first thing we want to do in R is we'll open up the code for logistic regression. So that is in chapter 8, and the code is called logistic regression. So I'm going to go ahead and make these a little bigger so we can see them a little easier. So the first thing we always do is to see whether or not there are any packages we need to install. In this case, there are none. The logistic regression is part of the base package of R. So we'll go ahead and just set our random number generating seed. The next step is we're going to load in the data. In this case, we have a data file that's called retail_logit. Now, once again, if we want to see what's in this data, we can click over into our console window and type head logit. And we'll see the first 6 rows of data. In this case, it's the first 6 customers. Now, from chapter 7, if you remember, we looked at the RFM score. So we have the R revenue. We have or R would be recency. We have M, the monetary revenue. We have F, which is number of orders, right? This is our frequency, and we have the recency here. In addition to that, we observe whether that customer purchased or not during the campaign window. And we also have a few pieces of demographic information. We have whether that customer is listed as being married or not, their income level in thousands of dollars, and whether or not they're a loyalty card member of our loyalty program. We also have their zip code, but we won't use that for the running the logistic regression. So the next step we have is we actually want to create a few variables based on the data we have. One variable we're going to create frequency squared. So we're going to create a variable called number of orders 2, or raised to the second power, which is just the square of the number of orders. We're going to also take the natural log of revenue, because revenue tends to be a very skewed variable, where the average revenue and the median aren't usually very close to each other. There's always a few customers who spend a lot of money. So we're going to take the log, and in this case, because some people may have revenue of 0 during this time period, we're going to add 1 to make sure we don't get any missing values. So we'll go ahead and create these 2 variables. And that should just add these 2 columns to the end of our data. The next step is to run the logistic regression. In this case, our formula is going to be the outcome variable purchase. That's that 0, 1 variable of did they purchase during the campaign or not. And then we have all of our independent variables, revenue. So we're going to use the natural log of revenue, frequency squared, recency, loyalty card, married, income. We're going to tell it that the data comes from this logit table and that the binomial logistic regression is what we want to run. This next line summary is just going to summarize the results for us to see. So we'll go ahead and highlight this whole piece, run, and we'll see that when we run it, we get the results of the logistic regression. So in this case, we're going to see here are the column that says estimate. These are our coefficients for the model. Our standard errors are, in this case, listed as z-values. These are essentially our tests of significance, and our p-value here at the end, right? More stars, more asterisk stars means more significant. So all of our variables are significant at least 1%, with many of them being significant at less than 0.1%, right? Now, next thing we might want to do is see how good our overall model fit is. One way to do that is to look at the R-squared. Now, this is a pseudo R-squared because it's not a linear regression. But if we highlight this, this will calculate our pseudo R-squared. So in this case, our pseudo R-squared is about 0.2. Now, it's hard to directly read into what that means for a logistic regression, but if we run similar models that are nested in each other, adding additional variables, we can see how much our R-squared grows as a result. We might also want to interpret the odds ratios of our variables. In this case, odds ratios are just the exponential of the coefficients. So we'll go ahead and run this. This will create a table here of our odds ratios. So for instance, you'll see here our odds ratio for log of revenue is 1.21. And the way I would interpret that is for each additional increase of log of revenue by 1 unit, we would see a 21.3% increase in the odds that the customer would be a purchaser during the campaign. Right? The dummy variables you can read the similar way. For married, you see here 2.19. For someone who's married versus not married, the odds of them purchasing during the campaign are 119% higher. Right? Remember, we read the odds ratio as being the e to the beta minus 1. Last thing we're going to do is predict the responses. The prediction of the response just is going to add a column which will predict the probability that each of the people in our sample, each of the customers, would purchase. So that's what this will do. And that just added another column to the end of our data. And the last thing we're going to do is export the data so that we can take it over into Tableau to look at some visualizations. So to export, we're going to run this last line, and we're going to create a file in our chapter 8 folder called logit_pred.csv. Okay, so now that that's there, we can now go switch over to Tableau. And in Tableau, we'll be able to visualize some of our results. So first step, we're going to bring in that data we just created. Right, this one is called logit_pred. When we do that, you'll see that we get the table. And as we scroll to the right, you will see the variables we created, as well as a column that has the predicted value probability of purchase for each of the customers in our data set. So let's go ahead and go over to sheet 1 so we can do some visualization. All right, so step 1 here is we're going to actually just look at some individual data before we aggregate it. So if we want to do that, we have some customer IDs. So Tableau knows that those are dimensions, which is great. So we'll go ahead and double click on customer ID, and you'll see that Tableau adds that to the sheet where each of the rows is going to be a customer ID, right? And we can add columns to this data. So perhaps one column we'd want to look at would be the actual probability. So that would be our predict. We can double click on that. Now that adds predict column here. And if we also want to look at whether they actually bought or not, we can double click on purchase. And now you see here we have a column for predict and a column for whether they purchased or not. Right now, there's ways to then make this a little bit easier to see. One is we can actually add color, right? So maybe the first thing we want to do is look at those that we predict that are above or below the break-even point, right? So we can drag predict to color under marks, and it will shade them different colors. Now here, this is hard to potentially read, so we're going to come over here and clean this up. We'll go to the top right here and choose edit colors. Now, perhaps we can use a more diverging color. So we're going to pick orange, blue, diverging. Here, we're going to just sort them into above or below the break-even point. So we're going to choose 2 stepped colors. And under advanced, we're going to center this at that break-even rate. So that was 15.63%. When we apply that, we see we get some nice divergent color here between the red and the blue. Right? Red here is equal to cases that are below the break-even point, and blue is equal to cases that are above the break-even point. Right? So the next thing we could do is we could make this a little bit easier to see, make it a little bigger. To do that, we'll go to Format, Font. Let's choose, we could choose 16 for our font. So now these are a lot bigger. Maybe we can make it a little easier to see by dragging this out to the right a little bit. So now we have a customer ID. We have the probability, the predicted they're going to purchase based on our model, and we have whether they purchased or not. We can title this sheet. So let's title it predicted versus actual purchase for each customer. Right? And then we might want to sort the data and sort of look at how well we're doing here, right? So we might want to say, among those that we've predicted very high, right, how good is our model at doing that? So one way to do that is if you highlight over predict, you see there's a little sort button here. We're going to click sort. Now this is sorting our customers based on the likelihood that they're going to purchase. You can see we're sorting from high to low. So all of these are going to be blue because we've gone ahead and created the divergent color based on the break-even rate. So they're all above the break-even rate. Here we might want to see among those whether purchase happened or not. So if we want to change the coloring, or essentially how we're delineating between the groups, we could change the color from predict. So if we take purchase and drag it to color, and here it's going to change the color back to this sort of light to dark blue. So we're going to edit the color. We'll pick again orange blue diverging. 2 steps. We can just center it at 0.5. It doesn't matter. We can center it at 1 even. And we can see here that anything 1 or higher is blue, anything less than 1, which is our 0 there, is red. So we can actually see here that if we sort people based on likelihood of buying, that among these first rows of our customers in our data, that we're pretty accurate. Only 1 case do we see here where we predicted a really high likelihood of someone buying, and actually this person did not buy during the campaign. Okay. So this is a way to look at the data at the individual customer level. We can also look at the data by aggregating it up and looking at our predictive accuracy, our hit rate. So to do that, we're going to go to a second sheet. Right now in this sheet, we're going to actually have to create a number of calculated fields to capture this information. So the first calculated field, remember calculated fields we can create by either right-clicking in this area and choosing create calculated field, or we can go to analysis, create calculated field. The first calculated field we're going to create is just a counter that's going to help us when we sum up these different groups. So in this case, we're just going to create one called number of records. And it's a counter, so we're just going to set it equal to 1. So each row will get a count of 1. The next fields we're going to create are the predictive accuracy. So when we get it correct, when we get it wrong. So the first one we're going to create is going to be called, well, first, before that, we can just take the predicted value here and make sure that we change it from the actual probability to a 0 and 1. So we're just going to say if predict is greater than or equal to our break-even rate, which was 0.1563, then 1, else 0. And then we say end to end our if statement. So this is just going to create a field that's going to be equal to 0 if the the prediction is below break even, and 1 if it's at break even or higher. Now we'll create those classifications of correct or incorrect predictions. Our first type of prediction we're going to create is going to be what we call our true negative, which means this is the case in which we predicted 0 and it actually was 0. So to do this, we're going to count. I'm going to go ahead and just close, delete the end parentheses there. So we're going to say if purchase equals 0 and our predict purchase equals 0. This is the case where we guessed no and it was no. Then we'll count the number of records. Right, and that'll end our if statement. We'll close the parentheses there. We're going to create a calculated field for our true positive. Right, this is the case in which we guessed you would buy and you actually did. So we're going to again count if purchase equals 1 and predict purchase equals 1, then we'll count the number of records. Then we need to create the 2 instances where we guessed incorrectly. So 1 is our false negative, right? This count is going to be equal to the case where we guessed yes, or we guessed no, and you actually did buy, right? So if you did buy, so purchase equals 1, and we predicted no, we're going to count the number of records there. Then we're going to create the last calculated field, which is called false positive. And this is the case where we predicted yes, but you didn't buy. So we'll say if purchase equals 0 and predict purchase equals 1, then count the number of records. Right. And the last field we're going to create is one that capturing how often we were right overall from a percentage term. So we'll call that our hit rate. So a hit rate in this case is just going to be equal to our number of times we guessed correctly that you didn't buy, plus the number of times we guessed correctly and you did, divided by, in this case, our incorrect no's, our incorrect yes, as well as the correct no's and the correct yes. All right, so that'll be our hit rate. Once we have these, now we can actually put them into a table. Now, the easiest way to make a table like this, where you're going to be bringing in a number of rows, is you can actually just double click on measure names. And you'll see when you do that, it'll go ahead and think, I'm going to put all the measure names onto the sheet. First of all, we're going to drag measure names from columns down to rows. That'll create more of a stack here. Then the nice thing is we can click the down arrow here and choose edit filter and go through and pick the things we actually do want. So we'll start by just saying none, and that'll take away all of them. So let's go ahead and add back our false negative and our false positive. We also want the hit rate. And then lastly, we want our true negative and true positive. Say apply there. So first thing we'll do is we'll make this a little bit bigger. Let's go to Format, Font, and choose, let's say, 16. That makes that a little bit bigger. The second is we'll go ahead and drag hit rate from the measure values here down to the bottom, because that'll be sort of our total. Now, hit rate isn't 100%. It just doesn't know that we want to represent this as a percentage. So if we want to change hit rate, we can go here to this measure values down arrow and choose format. And we can tell it that hit rate is actually a percentage and not a rounded integer. When we do that, we can see here that hit rate does actually come out to be a percentage. Lastly, we can go ahead and change the title of this. So in this case, this is our hit rate or confusion matrix table. Right? And what we see here is if we use the break-even rate as our way to divide the yeses and the nos, we can see how often we guess incorrectly, how often we guess correctly, and overall we're right not quite 70% of the time. And this is based on maximizing our profitability, right? We could see how good the model is. And in that case, all we would do is we would change our way that we calculate hit rate by changing our predicted purchase. So if we right click on that and choose edit and change it from the break even rate to changing it, the model predicts best at 50%. Right, so it's going to guess yes whenever the predicted probability is 0.5 or higher and no when it's less than 0.5. And we say, okay, we can see that immediately changes our hit rate in our table because we've changed how we've sorted people into these different categories. And it turns out when we use 50-50, our model fits pretty good. In fact, we're guessing right about 84, a little over 84.5% of the time. Now that goes back to the question, would you rather be right or would you rather be profitable? And in this case, we can see when we're right, we actually guess a lot more zeros than when we want to be more profitable. So we're willing to send our, in this case, our catalog or our emails to people more often, even when it's unlikely that they're going to buy, because it's cheaper to do that than it is to try just to be correct the most number of times. So lastly, we'll just go ahead and save this. In this case, we're going to again save it as a Tableau packaged workbook. We're going to call it Logistic Regression and save it in our folder. So now what you have is you have how to do the logistic regression analysis and how to visualize the results as well as the hit rate table in Tableau.